Ants are remarkable creatures that employ a wide range of strategies to protect themselves from their enemies. Despite their small size, they exhibit a level of organization, cooperation, and ingenuity that rivals that of larger animals. Their ability to survive in diverse environments and fend off predators or threats is rooted in their highly evolved social structures, physical adaptations, and behavioral tactics. These strategies vary widely among different species, reflecting their ecological niches and evolutionary pressures. One of the most critical aspects of ant defense lies in their social structure. Ants live in colonies that can range from a few dozen individuals to millions, depending on the species. This collective organization provides them with strength in numbers. When a threat is detected, ants communicate using pheromones, chemical signals that convey information about danger, food sources, or the need for assistance. These pheromones act as a sophisticated alarm system, enabling rapid communication and a coordinated response. Upon detecting danger, worker ants mobilize quickly, forming defensive lines or swarms to protect the colony. This teamwork is a powerful deterrent, as the combined efforts of hundreds or thousands of ants can overwhelm many potential predators. Ants also rely on their physical adaptations for protection. Their exoskeletons, made of a tough material called chitin, provide a robust barrier against physical attacks. Some ants have evolved specialized body structures for defense. For example, soldier ants in certain species have large mandibles designed for biting and fighting. These mandibles can deliver painful bites to intruders, discouraging further aggression. In some cases, the mandibles are so powerful that they can even be used to cut through tough materials or hold onto predators during a fight. Other species have developed spines or other structural modifications that make them harder to grasp or harm. In addition to physical adaptations, many ants possess chemical defenses. One of the most well-known examples is the ability of certain species to spray formic acid at their enemies. This substance is not only irritating but can also be toxic to many predators. For instance, wood ants are notorious for their formic acid sprays, which they can release in a fine mist when threatened. Some ants combine chemical and physical tactics by biting an enemy and simultaneously spraying formic acid into the wound, increasing the effectiveness of the defense. Other species, like fire ants, rely on venomous stings to subdue threats. The venom of fire ants contains alkaloid compounds that cause intense pain and inflammation in their victims. This potent sting is a significant deterrent to larger predators and also helps these ants capture prey. Behaviorally, ants exhibit a range of defensive tactics that enhance their survival. Some species, such as the trap-jaw ants, have incredibly fast mandibles that can snap shut with astonishing speed and force. These mandibles are not only effective for capturing prey but also serve as a defense mechanism. If a predator approaches, the ant can deliver a swift and painful bite, often driving the predator away. Other species adopt more strategic approaches to defense. Leafcutter ants, for example, have a caste system where specific individuals, known as soldier ants, are dedicated to protecting the colony. These soldiers patrol the nest and the surrounding area, constantly on the lookout for potential threats. When an intruder is spotted, they engage in combat, using their powerful jaws and teamwork to neutralize the threat. Meanwhile, the worker ants continue their tasks undisturbed, ensuring the colony's survival and productivity. Camouflage and mimicry also play vital roles in ant defense. Some ants have evolved to blend in with their surroundings, making them less visible to predators. For instance, the golden tortoise ant has a reflective body that mimics the appearance of sunlight glinting off leaves, effectively rendering it invisible to many predators. Other ants adopt a strategy called mimicry, where they imitate the appearance or behavior of other, more dangerous species. By resembling venomous or unpalatable creatures, these ants can deter predators without engaging in direct combat. Certain ant species have developed sacrificial behaviors to protect their colonies. In a phenomenon known as autophasis, some ants can rupture their own bodies to release sticky or toxic substances onto an enemy. This self-sacrificial act not only immobilizes or harms the predator but also serves as a warning to other members of the colony, allowing them to prepare for further threats. An example of this behavior is found in the carpenter ant species Camponotus saundersii, which has specialized glands filled with a sticky, toxic substance. When cornered, these ants contract their abdominal muscles, causing the glands to burst and release the substance onto their attackers. Many species construct complex nests designed to deter or slow down intruders. These nests often have narrow entrances, winding tunnels, and chambers that make it difficult for predators to navigate. Some ants, like army ants, are nomadic and do not build permanent nests. Instead, they form temporary bivouacs using their own bodies, creating a living fortress that can quickly relocate when threatened. The ability to move and adapt their defensive strategies gives these ants a significant survival advantage. In addition to these tactics, ants often form symbiotic relationships with other organisms to enhance their protection. For instance, some ants cultivate relationships with aggressive predatory insects like certain species of wasps or spiders, which act as bodyguards for the ant colony. In return, the ants provide these allies with food or shelter. Similarly, ants often protect plants that offer them food in the form of nectar or shelter in specialized structures. In exchange, the ants defend the plants from herbivores or other threats. These mutualistic relationships extend the ants' defensive capabilities beyond their immediate colony. The diversity of ant species means that their defensive strategies are incredibly varied and often tailored to their specific environments. Desert ants, for example, rely on their speed and agility to evade predators, while tropical ants may use their dense jungle habitats to hide or escape. Some ants even employ chemical deception, releasing substances that confuse or mislead predators. For instance, certain ants can produce pheromones that mimic those of their enemies, disrupting the predator's ability to locate or attack them effectively. Moreover, ants demonstrate an impressive ability to learn and adapt to new threats. They can recognize recurring predators and adjust their defensive strategies accordingly. If a particular tactic proves ineffective, ants are capable of experimenting with new approaches or combining multiple methods to achieve better results. This adaptability is a key factor in their survival and success as a species. In summary, ants protect themselves from their enemies through a combination of social organization, physical adaptations, chemical defenses, behavioral tactics, and symbiotic relationships. Their strategies are as diverse as the environments they inhabit, reflecting millions of years of evolution and adaptation. Whether through teamwork, specialized body structures, venomous stings, or strategic alliances, ants have developed an array of mechanisms to ensure their survival in the face of countless challenges. These tiny yet formidable creatures continue to fascinate scientists and nature enthusiasts alike, serving as a testament to the power of cooperation, innovation, and resilience in the natural world. Thanks for watching. Subscribe for more.